Okay, so this is just Unit 4, Objective 9 continued. I feel like we've done Objective 9, I don't know, 5 times now. So, but this is solved by graphing. And then also the 2 square root problems. Okay. So we're going to do an example at the same time we write the steps next to it. So example 1. For so there's our problem. So we know how to solve this algebraically, like we would square both sides, and then when we square both sides, we factor it, and then set each factor equal to 0, right? So in our homework, they're going to have it already split up as 2 functions, okay? So, but we're going to write down that step 1 is to split it into 2 functions. So we're going to have f of x equal the left side, and then g of x equal the right side. And this is just to get us used to how do we solve it if it's not already set up for us by graphing. So how do we solve for it if it's not already set up by graphing? So f of x. Okay, so equals the left side. So then Madison, what is f of x going to equal? Okay, good. Okay. And then next to that, I'm going to do my g of x. Okay. And then Travis, what's my g of x going to be? Okay, good. And so now we have to graph both functions. So we're going to find, for both of these, we're going to find our vertex or start point, right? So they don't both have what we call a vertex, but they both have a shift. So we're going to find that. And then we're going to find our slope or stretch, depending upon what type of graph we have, right? So on linears, we have slopes, or we call it a slope, and then everything else we call it a stretch. And so the vertex is what are we adding and subtracting to each of the different variables. Our stretch or slope is what are we multiplying to x, right? So I'm going to put these and make sure these are in standard form though before I do that. So I'm going to kind of do something like this just to make sure I know I'm working on 2 different equations here, right? So for this one I have just y equals the square root of x minus 2. And there's nothing outside of the square root, right? And so this is, the minus 2 is affecting the x, not the y, and there's nothing affecting the y. Okay? So I don't have to add anything over or subtract anything over. Okay, so then let's talk about our vertex. I'm just going to use V for vertex. Okay. And then Thea, what's our vertex here? Do we use 2 or negative 2? I'm sorry? Yeah, okay, good. And then if there's nothing adding to the y, what do we use for that? 0. Okay. And then I'm going to use S for stretch or slope, however we want to use that. So just a reminder, if we're missing a shift, we use 0, right? If we're not adding or subtracting something to a variable, we use 0 if we're missing a shift. But if we're missing the slope, do we use 0 for the slope? No, okay? So then what's going to be our slope or stretch? So Parker, what's our slope on this? 1, right? So we don't have any number in front here, right? No number in front, so we use 1. And then in this case, it's a stretch, right? Okay. So now let's do this problem. So y equals x minus 4. So it's been since Unit 1 since we've graphed lines, okay? Right? Unit 1 since we've graphed lines. And this is the part when I was looking at everybody's homework, it didn't look so hot. Okay? It looked like we all forgot how to graph lines, all but one. Okay? So for this one right here, the x minus 4, it looks like it's together, right? But it's really not. For things to be together, they have to be grouped somehow. So radicals are considered something being grouped, and parentheses are a grouping symbol. So the grouping symbol here is square roots. The grouping symbol here, since there's no square roots, has to be parentheses. Is that x minus 4 in parentheses? That minus 4 then does not belong to the x. It has to be grouped in parentheses to belong to the x. So if it doesn't belong to the x, I need to add it over to the y, right? So it does not belong to the x, so that means it belongs to the y. The only way it can belong to the x is if it's in a grouping symbol, like parentheses or square roots. And I know it's been forever since we've done these, okay? So in this case, this is not really a vertex, right, because it's not a squared or a square root. So we're going to just call it my start point. So I'm going to use the word start, okay? Okay, and then you're going to help me with this. So for the x, am I adding or subtracting anything to x? No. So do I use 0 or 1 when we're missing for our shift? 1. Or perhaps 0. Okay, good. Right? So if we're missing something that we're adding or subtracting, we use 0. If we're missing our stretch, we use 1, right? If we're missing a shift, we use 0. If we're missing a stretch, we use 1. And then what about for my k value? Is it 4 or negative 4? Okay, good job. Okay. And then I'm just going to use s for slope here. Slope or stretch. Okay, so then I look to see what am I multiplying to x, and then what am I multiplying to x here? What's implied? So if there's no number in front, what can we use? 1. Okay, good. So our slope is 1. So all we've done so far is find our vertex, find our slope or stretch. And so now we're ready to graph it. So we're still in step 2. So step 2 is kind of long. And it always feels longer, right, when we're explaining it than it does when we actually do it, because we can think at our own pace instead of at a class pace, which is always slower, right? Make sure I got enough here. So we're going to plot a bunch of extra dots just because when we're graphing not on graph paper, we can get off a little bit. So we want to make sure we do extra spots. Okay, so 0, negative 4, so I'm going to start with my line. So I'm going to go over 0, down 4. And then I'm graphing a straight line, and I know my slope is 1. So I'm going to do a bunch of extra dots here just because I don't really have graph paper. I guess I can draw in some lines for graph paper. I don't know if that's necessary. But whenever we solve by graphing, it's harder, right, if it's not on graph paper because we want to be very precise. We want to be precise. So I'm going to go up 1 over 1, and then I'm going to do it again, up 1 over 1, up 1 over 1. And I can only do this for lines, right? I can't do this for everything else. I can only do that for lines. And then hopefully that's enough. We'll find out. Okay, that's a perfectly straight line there. Okay. That's terrible. Good enough, though. Okay, so all I've done so far is graph my line. Now I have to graph my square root. Okay, so we're going to do that. Okay, so let's see here. Giselle, why don't you help us with this one? So what's my vertex on this one? 2, 0. So I'm going to go over 2, up 0. And then how do I use my slope or stretch? Up 1 over 1. Can I do that again when it's not a linear graph? No, right? I can't do it again. I can only do it once. So if I try to graph this, like I'm not going to be able to tell exactly where it crosses. I could be pretty close, but I can't tell exactly. So that means I need to do one more point, right? One more point on my square root. And if you remember, on my square root graph, I can always find another x value to plug in by counting 4 from here, right? So if I count from 4, so 1, 2, 3, 4, so I need to use that x value, right? So I was at 2, so 3, 4, 5, 6. So I'm going to use x equals 6 to substitute in, and that will always be a number I know the square root of, okay? So I'm going to use x equals 6. So I'm going to find f of 6. So I'm looking up here, right? Looking up here at the original. So that would be the square root. And then instead of x minus 2, I'm going to do 6 minus 2. And the square root of 4 is 2. So when x is equal to 6, my y value equals 2. So 1, 2. And so now when I graph that, I have my intersection. And so then step 3 is the intersection is my solution. And so in this case, that would be x equals 6, y equals 2. So as an ordered pair, that would be 6, 2. Okay, and then the last thing I want to talk about is make that connection with the extraneous roots. So you're going to have to know the connection with extraneous roots based on this, okay? They're going to ask you a question on the test. What's the connection with the extraneous roots? Okay, so for this part here, so that connection is that we know that when we're graphing a square root, we're just graphing this part right here, right? But is this what a parabola looks like? When we solve by factoring, we're really working with parabolas. We know parabolas have a U shape. So how would I draw in something to where instead of just graphing my square root, I'm actually graphing the whole thing, right? The parabola part. Because when I solve by factoring, I need to do parabolas. Yusuf, any ideas?
Don't you do the opposite?
I do the opposite, right? We do the reflection. So I'm going to use a dotted line. So I'm going to use a dotted line like this, okay? And so this dotted line right here, so I'm going to write it like that. My dotted line, this is what is finding the extraneous root. So if we want to find the extraneous root, I just need to do the reflection, right? I need to do the reflection. So what would be my extraneous root in this problem? It would be right here. So 1, 2, 3. So at x equals 3 is my extraneous root. So when we solve by graphing, right, we only see one intersection because when we're graphing a square root, we're only graphing the positive side of the parabola. But if we do the reflection to find the other half of the parabola, that finds us that extraneous root as well. Parker?
What is x equals 3?
So when I did the flip of the graph here, so this is the top half of the parabola. This would be the bottom half. I look for where does it cross the line. So where does my dotted line cross the line? It crossed right here at 1, 2, 3 at x equals 3. Okay? We got it?
And what's x root? Is it next or?
Just regular.
No, x equals 3. No.
Oh, extraneous root.
Oh,
That's the abbreviation. Yeah, extraneous root. Or extra root. I mean, that's really what that's saying, right? There's an extra root in the problem. Okay. Any questions? Okay. So